Hello dear students of +1 medical and non-medical. First of all, welcome you all on my YouTube channel Physics Concepts and Motivational Talks. ਮੈਨੂੰ ਪੂਰੀ ਉਮੀਦ ਹੈ ਤੁਸੀਂ ਵਧੀਆ ਢੰਗ ਨਾਲ ਆਪਣੀ ਸਟੱਡੀ ਕਰ ਰਹੇ ਹੋਵੋਗੇ, ਆਪਣੇ ਕੰਪੀਟੀਸ਼ਨ ਐਗਜ਼ਾਮ ਦੀ ਤਿਆਰੀ ਕਰ ਰਹੇ ਹੋਵੋਗੇ। ਜਦੋਂ ਅਸੀਂ ਕੋਈ ਐਗਜ਼ਾਮ ਦੀ ਤਿਆਰੀ ਕਰਦੇ ਹਾਂ ਜਾਂ ਕੋਈ ਵੀ ਕੰਮ ਕਰਦੇ ਹਾਂ ਤਾਂ ਸਾਨੂੰ ਕੁਝ ਮੁਸ਼ਕਲਾਂ ਵੀ ਆਉਂਦੀਆਂ, ਚੈਲੰਜ ਆਉਂਦੇ ਹੈ, ਲੇਕਿਨ ਉਹ ਚੈਲੰਜਸ ਨੂੰ ਪਾਰ ਕਰਦੇ ਹੋਏ, ਮੁਸ਼ਕਲਾਂ ਨੂੰ ਦੂਰ ਕਰਦੇ ਹੋਏ ਅਸੀਂ ਅੱਗੇ ਵਧਣਾ ਹੁੰਦਾ ਹੈ। ਜਦੋਂ ਅਸੀਂ ਕੰਮ ਕਰਦੇ ਹਾਂ ਸਾਥੋਂ ਗਲਤੀਆਂ ਵੀ ਹੁੰਦੀਆਂ, ਲੇਕਿਨ ਉਹਨਾਂ ਗਲਤੀਆਂ ਤੋਂ ਸਿੱਖਣਾ ਹੁੰਦਾ ਹੈ। ਸੋ ਕਹਿੰਦੇ ਡਿੱਗਣਾ ਗੁਨਾਹ ਨਹੀਂ, ਲੇਕਿਨ ਡਿੱਗ ਕੇ ਨਾ ਉੱਠਣਾ ਬਹੁਤ ਵੱਡਾ ਗੁਨਾਹ ਹੈ। ਸੋ ਜਦੋਂ ਕੰਮ ਕਰੋਗੇ ਗਲਤੀਆਂ ਹੋਣਗੀਆਂ, ਲੇਕਿਨ ਗਲਤੀਆਂ ਵਾਰ-ਵਾਰ ਰਿਪੀਟ ਨਹੀਂ ਕਰਨੀਆਂ ਔਰ ਆਪਣੇ ਗਲਤੀਆਂ ਤੋਂ ਸਿੱਖਦੇ ਹੋਏ ਅੱਗੇ ਵਧਦੇ ਰਹਿਣਾ ਚਾਹੀਦਾ ਹੈ। ਸੋ ਅੱਜ ਮੈਂ ਟੌਪਿਕ ਲੈ ਕੇ ਆਇਆ ਐਪਲੀਕੇਸ਼ਨਸ ਆਫ ਡਾਇਮੈਂਸ਼ਨ ਐਨਾਲਿਸਿਸ, ਕਿਉਂਕਿ ਫਸਟ ਸੈਕਿੰਡ ਲੈਕਚਰ 'ਚ ਮੈਂ कवर कर चुके हैं सिस्टम ऑफ यूनिट्स एंड डिमेंशनल फार्मूला ऑफ वेरियस फिजिकल क्वांटिटीज। टुडे आई एम गोइंग टू डिस्कस the various applications and limitations of dimensional analysis. So first of all, the first application of dimension analysis, using this method of dimensions we can check the accuracy of a given relation. दुनिया की कोई भी रिलेशन तुहाडे सामने पई होवे, ਅਸੀਂ ਦੱਸ ਸਕਦੇ ਹਾਂ ਕਿ ਇਹ ਇਕੁਏਸ਼ਨ ਠੀਕ ਹੈ ਜਾਂ ਗਲਤ ਹੈ। ਸਿਰਫ ਕੁਝ ਸਾਨੂੰ ਡਾਇਮੈਂਸ਼ਨਲ ਫਾਰਮੂਲੇ ਆਉਣੇ ਚਾਹੀਦੇ ਹੈ without the knowledge of physics laws. So first application is to check the accuracy of a given relation. For example, the given equation is T is equal to 2 pi under root L upon G, equation number 1. Basically this is the equation of time period of simple pendulum having length L and G the acceleration due to gravity. Now, because we are studying first chapter and we have not derived this expression using physics laws, so just check the accuracy of this relation. We use the principle of homogeneity. What is the principle of homogeneity? It states that if an expression expressing a physical quantity is correct, then dimensional formula of left hand side must be equal to dimensional formula of right hand side. जो लेफ्ट हैंड साइड पे होएगा फिजिकल क्वांटिटी के यूनिट्स वही राइट हैंड साइड पे होने चाहिए। We cannot write 1 kg is equal to 100 centimeter. This is impossible. This is incorrect. So if T is equal to time period of simple pendulum, then we can write dimensional formula of left hand side. Very simple. Time T1. Dimension for right hand side. 2 pi is constant. It has no dimensions. Square root L length of simple pendulum, L1 G is the acceleration due to gravity. It is L1 T minus 2. So L1 cancels. So T2 square root means T1. So we see that dimensional formula of left hand side and dimensional formula of right hand side both are equal. It means this given equation is correct in accordance with the principle of homogeneity. Second, so you can check accuracy of any equation. So you can practice by writing, for example, equation of centripetal force F is equal to mv square by r. You can practice by yourself. Simply you have to write dimension of left hand side and right hand side. If dimensional formula comes out to be same, equation is correct. If dimensional formula of left hand side and right hand side doesn't come to be same, then equation is incorrect. Second is derivation. So using this method of dimensions, we can derive an expression for a physical quantity by simply knowing the factors upon which the physical quantity depends. Now you have derived expression for same expression for time period of simple pendulum. Factors will be given to you, which may depend upon mass of the bob, metallic bob, length of simple pendulum, and acceleration due to gravity. So these are three factors M, L, and G upon which time period of simple pendulum may depend. So it is given to you. Now therefore let A, B, C be the dimensions of M, L, and G. We have to find the values of A, B, and C. K is a constant of proportionality. So let T is equal to K M power A, L power B, G power C. This is equation number 1. Now this equation is for time period of simple pendulum. But we have to evaluate the values of A, B, and C as well as K. Now write dimension formula on both sides. T M0 L0 T1. K constant, no dimensions. This is constant of proportionality. M1 power A. Length L1 power B. G L1 T minus 2 power C. Simplify it. It comes out M power A, L power B from here, L power C from here. So it will be L plus B plus C. T power minus 2C after simplification. So now we have M0 L0 T1 is equal to M power A, L power B plus C, T power minus 2C. Now if this equation is correct, then corresponding powers of M, L and T must be same. So comparing powers of M, L and T on both sides, we have A is equal to 0. B plus C is equal to 0. Minus 2C is equal to 1. So here A is equal to 0. C comes out to be from this equation minus half and B is equal to minus C. So therefore B comes out to be plus half. So value of A 0 simple, C minus half and B is equal to plus half. Substitute these values of A, B, C in equation number 1. So we have T is equal to K M power 0, L power half, G power minus half, or is equal to K under root L upon G. And from experiments, value of K is 2 pi. You can leave it K here as, but if you know the value of K is equal to 2 pi, because we cannot find the value of constants occurring in the relation using this method of dimensions. It's a limitation of dimension analysis. So it means we have proved T is equal to 2 pi under root L upon G. Or you can say simply T is proportional to L upon and G under root. So using method of dimensions, we can derive an expression for a physical quantity by simply knowing the factors upon which it depends without the knowledge of any physics law applied to this equation. Then third is conversion. We can convert a physical quantity from one system into another system using method of dimensions. For example, we have to convert a system for suppose in one system M1 L1 T1 are the fundamental units of mass, length and time in one system, where N1 is a number multiplied. M2 L2 T2 are the fundamental units of mass, length and time in second system, where N2 is a number multiplied. Let A, B and C be the dimensions of mass, length and time respectively. Then we have proved whatever may be the system of measurements, the magnitude of physical quantity must remain the same. That is N1 U1 is equal to N2 U2, or N1 U1 means unit, M1 power A, L1 power B, T1 power C is equal to N2 M2 power A, L2 power B, T2 power C. Or from here we can find N2 N1 M1 upon M2 power A, L1 upon L2 power B, T1 upon T2 power C. So you have to remember this formula where you have to convert a physical quantity from one system into another system. That is, we have to find number N2. Number N1 will be given to you. Unit in first system will be given to you. So we have to find the number multiplier. That is, we have to convert a physical quantity from one system into another system. For example, when you have to convert 1 Newton into dyne. Now, Newton the unit of force, you know. Then first of all write dimensional formula of force, which is M1 L1 T minus 2. From this dimensional formula, you will get values of A, B and C. That is dimensions of mass, length and time. So A is equal to 1, B is equal to 1, C is equal to minus 2, N1 is equal to 1, because we have to convert 1 Newton. If it is 2 Newton, then N1 will be 2. If it is 5 Newton, then N1 will be 5. So we have to convert 1 Newton, that is N1 is 1. N2 we have to calculate. Dyne is given, unit is given, U2 is given. So then by applying this formula, N2 is equal to N1 1 upon M1 upon M2 power A, L1 upon L2 power B, T1 upon T2 power C. Substitute the values of, now we are going from SI to CJ system. So therefore, mass M1 will be 1 kg, L1 will be 1 meter, T1 will be 1 second, M2 will be 1 gram, L2 will be 1 centimeter, 1 second. Powers 1, 1, minus 2. Simplify it. 1 kg is equal to 1000 gram. 1 meter is equal to 100 centimeters. Simplify it. You will get N2 is equal to 10 raised to 5. It means N2 comes out to be 10 raised to 5. Therefore, 1 Newton is equal to 10 raised to 5 dyne. So you can simply convert a physical quantity from one system to another system using this formula, simple formula. That is, we have to find number multiplier in the second system in which we have to convert the physical quantity. So it is N1, M1 upon M2 power A, L1 upon L2 power B, T1 upon T2 power C, and substitute the values accordingly and you will get the number N2. So 1 Newton is equal to 10 raised to 5 dyne. Similarly, you can practice to convert 1 joule into erg. Joule is unit of energy. You have to write dimension formula of energy and then find values of ABC and substitute in this formula. You will get 1 joule is equal to 10 raised to 7 erg. So you can convert any physical quantity from one system into another system. This is third application. Fourth application, we can find the units of constants occurring in the relation. For example, x is equal to a plus bt plus ct square. So this equation contains more than one term on either side and one term on one side. So if we know the units of x and t, we can find dimensions as well as units of a, b and c. That is a constant occurring in this relation. Very simple. Why? Because the quantities of similar nature can be added or subtracted. We cannot add mass into time, mass with time. So mass can be added to mass, time can be added or subtracted to time. Length can be added or subtracted from length. So therefore, x is equal to a plus bt plus ct square. If this equation is given and x is in meter, t is in second, we have to find constants a, b, c. It means it is very clear that every term on right hand side, that is a, bt and ct square, must have dimensions of x, that is length. So a must have dimensions of x, that is length L1. Similarly, bt, the whole term, must have dimensions of length. This implies b is equal to L upon t or L1 t minus 1. So it means if length is in meter, time in second, units of b will be meter per second. Ct square must have dimensions of L1 or c is equal to L1 upon T2 or L1 T minus 2. So if dimensions of length are meter, time in second, so c will be meter per second square. So by simply knowing dimensions of x and t, we can find dimensions of all the constants a, b and c occurring in this equation. You can practice by simply using the fact that quantities of similar nature can be added or subtracted. So these are the four applications of dimensional analysis. Number one, to check the accuracy of a given relation. We can check the accuracy of any relation using method of dimensions by simply knowing some dimensional formula. Second, we can derive an expression for a physical quantity which depends upon 2 or 3 factors. The factor should be given. Third is conversion. We can convert one physical quantity from one system into another system using this formula. N2 is equal to N1, M1 upon M2 power A, L1 upon L2 power B, T1 upon T2 power C. And fourth is we can find values of units of constants occurring in the relation which contain more than one or two terms on either side. So even it has four applications, but method of dimensions or dimension analysis has some limitations also. First limitation, from this equation we have taken k is equal to 2 pi from experiments. In derivation, 2 pi from experiments. So it means we cannot find the values of constants occurring in the relation. First limitation. Second, it doesn't tell us about the sign to be taken. Because in some questions there may be minus sign here, maybe plus sign here, we are taking plus sign. So it doesn't tell us about the sign to be taken. Third limitation is we cannot derive an expression for a physical quantity which depends upon more than 3 factors. More than 3 factors. because by comparing powers of m, l and t, we can find only 3 constants. So if a physical quantity depends on more than 3 factors, 4 or 5 factors, which is possible, so we cannot derive expression for that physical quantity. Fourth is, if we cannot derive expression for a physical quantity which contains trigonometric functions like sin x, cos x, tan x, because sin x, cos x, tan x is dimensionless. Logarithmic functions and like base e, base of log. So we cannot find expressions for those physical quantities which contain trigonometric logarithmic functions. Okay. So fifth application limitation is we cannot find expression for a physical quantity which contains more than one term on either side. That is, we cannot derive this equation using method of dimensions. We can find units of ABC, but we cannot derive this equation by knowing the factors upon which x depends. So these are the 5 limitations of dimensional analysis. So this is all about applications of dimension analysis and limitations of dimension analysis. In next video, I will discuss significant figures and some practical units. And in the next video, I will discuss errors of measurement in measurements. So very important. So उम्मीद है एप्लीकेशंस तो बिल्कुल समझ आ गई होंगी और थोड़ी प्रैक्टिस कर लो. इट इज़ वेरी ईजी. सो अपने दोस्तों मित्रों को दस के मेरा चैनल सबसक्राइब करो और मेरे नाल जुड़ो और लगातार थानू वीडियो छोटे छोटे टॉपिक्स दियाँ मिलदियां रहनियां और तुसी बहुत अगे ये सारा कुछ कर सकते हो. बी हैप्पी, चढ़ती कला च रहो और बस हसते हसते फिजिक्स पढ़ते चलो और तुसी बहुत कुछ कर सकते हो.